So you got to worry about the pain, right? Okay. So what are we going to go? We're going to go. Let's see. How do we want to do this? Actually, you know, it may be even easier to do this problem without law of sines. It may be even easier to do without law of sines. Has anybody done without the law of sines on this one? No? Soleil? No? So, say, you know that this is a right angle, right? No, can you assume that? Yeah. I don't know if you can assume that. Can you? I guess you do, because we've assumed that that's 46 degrees. Okay, that's the catch in there. You're assuming that that's right angle there. Okay. You know, I think you'll almost have to. I don't see an alternative to that. 500, 720. If you need an angle in there, so that's the only angle that shows up in the triangle. So, and we can only get that angle if it's 44 degrees. Okay, so let's assume that that's the case, okay? So let's do this alternative way and see if that works out, okay? I'm going to call this H. Does everybody see that sine 46 equals H over 500? Everybody see that? So then H is equal to 500 sine 46. Then if I come to this triangle here, okay, then I have cosine alpha is equal to H over 720. Does everybody buy that? Do I know what H is? Right there. Take that and shove it in there, and then find the inverse of that using cosine inverse and find alpha. So I'm going to pause here for a minute and you guys go 60.1. Okay. So then the bearing would be 180 plus 60.0303, which is 240.0303, which is the answer. Okay. So you got to assume in there that this is northeast. East-west line. All right, so everybody with me on that? Yes, Sharik? Sorry, Laura? You're adding the bearing. Remember, the bearing is with respect, sorry? Because it has to go clockwise. Yeah, that's the convention. Yeah, I mean, it explains it to you in the book right there. This is the plane flies 500 kilometers with a bearing of 316 degrees clockwise from north. So that's the convention. Okay. So in other words, what the bearing will be this angle here, that angle there. Okay. So that's 180 plus 60.0303. All right. Is everybody okay on this? All right. The next one was what? 29. Yeah. Okay. Okay, number 29. The circular arc of a railroad curve has a chord length of 3,000 feet and a central angle of 40 degrees. Okay, so a circular arc. So let's draw a circle. Has a length of 3,000 feet and a central angle of 40 degrees. So here's my central angle. This is 40 degrees. That's my central angle. Okay? And here's my circular arc. That's my circular arc right there. Okay, and the length and the length of the chord is 3,000 feet, right? So the chord would be this straight line here. Okay, so this is 3,000 feet. Okay, what's it asking you to do? Find the radius of the circular arc. So they want you to find r. Okay, so if I take this triangle out, it looks like this. This is 40 degrees. I don't know why they've thrown this problem in here. To me, this looks like a review problem with a bit of geometry that you need to know. Okay, this is 3,000 feet. This is r. This is r. Okay, what kind of triangle is this? What's it called? From geometry. Sorry? Isosceles triangle. That's an isosceles triangle. In an isosceles triangle, if you draw a right angle from the vertex to the base, what does it do to the base? Exactly, splits it in half. What does it do to the angle? Splits it in half as well. So then this would be 20 degrees. This would be 1,500 feet. Yeah, I don't know why they've thrown this angle in here. I mean, I don't see how they could want you to... Well, okay, maybe there's a way of doing law of sines. Again, that'll rely on geometry. So let me finish this method here first. Okay, let me finish this method here first. So does everybody see that sine 20 is equal to 1,500 over r? Everybody see that? So then r is equal to 15 sine 20. Is everybody on that? Yes? Okay. Can you guys work that out? And I'll pause here for a minute. Let's... this problem that's using law of sines, okay? It's going to require some more geometry, okay? So let's go back to the triangle, okay? This is 40 degrees. This is 3,000 feet, okay? In an isosceles triangle, what can you say about the two base angles? They're equal. So what would they be? 70 each. What kind of triangle does this become? Angle, angle, side, right? Angle, angle, side, or even angle, side, angle. Either way, you can still use law of sines. You can still use law of sines. So you got r over sine 70 is equal to 3,000 over sine 40. Can you smoke this one and see you get the same answer? Anybody remember the formula?